Hello dear students, let us solve some of the exercise questions. The first question tells us that calculate the molecular mass of the following. First, H2O. Using the data provided in the table that we have discussed, molecular mass of H2O, that means the 2 into the atomic mass of hydrogen plus 1 into the atomic mass of oxygen. Atomic mass of hydrogen is 1 and oxygen is 16, so 2 into 1 plus 1 into 16, that gives us the 18 gram per mole. Same way, if we want to calculate for CO2, molecular mass of CO2 is equal to 1 into C plus 2 into O. Carbon atomic mass for 12, oxygen it is 16, so 1 into 12 plus 2 into 16. Ultimately, we get 44 gram per mole. Same way, we can calculate for the third species. That is what it is known as the Na2SO4 sodium sulfate. Molecular mass of sodium sulfate is 2 into Na plus 1 into S plus 4 into O. This Na, S and O represents their atomic masses. So atomic mass of Na is 23, sulfur is 32 and oxygen is 16. By doing the calculation, we get 142 gram per mole. Now we need to understand about the mass percent of element or percentage composition. It is a calculation that is based on the percentage. It means mass in gram of the each element if total mass of the compound is 100 gram. Let us look at the exercise question. Calculate the mass percent of different elements in sodium sulfate Na2SO4. If in the previous question we have calculated the molecular mass of Na2SO4, and molecular mass of Na2SO4 we found is 142 gram per mole. By doing all this calculation, we have got it 142 gram per mole. Now we want to calculate the percentage composition of each element. So for Na2SO4 has a 2 sodium atom, that is 2 into 23, because 23 is the atomic mass of sodium, and ultimately 46 gram per mole. Same way, 1 S atom, that is 1 into 32, that is 32 gram per mole, and 4 O atom, that is 4 into 16, that is the atomic mass of oxygen, will give us the 64 gram per mole. Now 142 gram of Na2SO4, we have 46 gram of sodium, whereas 32 gram of sulfur and 64 gram of oxygen. So if we have 100 gram of Na2SO4, then we can find out the percentage of Na. That will be 46 divided by 142 multiplied by 100. For sulfur, we will get 32 divided by 142 multiplied by 100. And for oxygen, we will get 64 divided by 142. 64 divided by 142 multiplied by 100. So it simply leads us, the percentage of Na is the 46 divided by 142 multiplied by 100, that gives us the 32.39%. 32 divided by 142 multiplied by 100 will give us the 22.54%, and 64 divided by 142 multiplied by 100 will give us the 45.07%. So we can easily understand, or we can easily write the formula that percentage composition of an element is equal to element's atomic mass divided by the molecular mass of compound multiplied by hundreds. So here element's atomic mass, like instead of element's atomic mass, we can write here the total mass of atoms of element, then it would be far better. So we can even write the total mass of element in a compound. Or you can write the number of atom multiplied by atomic mass. So this is how we can find out the simple. Now we have the another concept which is known as the mole concept. We have already studied this concept, but just we are going to revise this concept. Avogadro number is Na, that is 6.022 into 10 to the power 23. If we have a number of moles, then we can convert the number of moles into number of species, that is number of ions, number of atoms, or number of molecules, by multiplying it with the Avogadro number. And if number of species are given, that means number of ions, number of atoms or number of molecules are given, then by dividing them we can get their moles. Same way, if we have number of moles of some atoms or for element, then we can multiply it with the atomic mass and we get mass in gram. If we have molecules or if we have compounds, then the number of moles needs to be multiplied by the molecular mass so that we can get the mass in gram. But if you are given mass in gram, then you can divide, if we have element, then we should divide it with the atomic mass so that we can get the number of moles of that element. And if we have compound, then we'll have to divide it with the molar mass so that we can get the number of moles of that compound. To go from mass in gram to the number of species, we have to go via number of moles. So if mass in gram is given, then first we'll need to find out the number of moles and then the number of moles multiplied by Avogadro number to give us the number of species. Same way, if number of species is given, then we will have to divide it with the Avogadro number to get the number of moles, and then we can multiply it either with the atomic mass or molecular mass to get the mass in gram. So this is how we perform the various calculations. We have exercise question number 1.33. Calculate the number of atoms in each of the following. 52 moles of argon. So if we have 52 moles of argon, the atomic mass of argon is 40. So number of species, that is atom, that is number of moles multiplied by Avogadro number, that is 52 multiplied by 6.022 into 10 to the power 23. That is ultimately lead us to the 13144 multiplied by 10 to the power 25 atoms of argons. So here we have calculated the 50 moles of argons present, like atoms present in 50 moles of argon. Now if we have 52 U of helium, then we can easily calculate it, that 52 U of helium, that is mass of one atom of helium, is 4U. In 52 U of helium, number of atoms of helium is equal to 52 divided by 4. So here we have divided the mass in gram, or like mass in divided with the atomic mass, and that is why we get the number of atoms or number of see, this is how we can get the number of atoms. So we get in 52 U of helium we have 13 atoms of helium. Now if we have 52 gram of helium, then we are given the mass in gram and we need to find out the number of atoms. So first we will have to convert it into the moles. Mass in gram given, we need to first calculate the number of moles. So atomic mass of helium is 4 gram per moles, and moles of helium in 52 gram is equal to mass in gram divided by the atomic mass, that is 13 mole of helium, and then number of species or number of atom is equal to moles into Avogadro number, that is 13 multiplied by 6.022 into 10 to the power 23. That simply leads us to the answer 7.8286 into 10 to the power 24 atoms of helium. So this is how we can do all those calculations. We have exercise question 1.28. Which one of the following will have the largest number of atoms? That we shall do in some other video. I hope, my dear students, you are enjoying your studies. Happy learning.